Have you ever just stopped and wondered how a giraffe supports that ridiculously long neck, or how an owl can pull off that full circle head turn? Well, the answers are all hidden in the architecture of the spine. It's this incredible story of evolution, of form, and of function. And today, we're going to unlock the secrets of the neck, one bone at a time. And it all starts with something we've all seen, right? That super adorable head tilt your dog gives you. Well, that simple little movement is actually an engineering marvel. So today, we're going to pop the hood and see exactly how that machine works. All right, so before we can really appreciate the next super unique design, we got to understand the bigger picture it's a part of. We're talking about the backbone, your body's central support system. So at its core, the vertebral column, or the spine, is basically a stack of these individual bones called vertebrae. They articulate, which is just a fancy way of saying they connect in a way that allows for movement. And altogether, they form this amazing protective tunnel for the super important spinal cord. But this whole column isn't all the same. If you look at this cow's skeleton, you can see it's actually broken down into 5 distinct regions, and each one is shaped for the specific job it has to do. You've got the thoracic region that anchors the ribs, the lumbar that supports that powerful lower back. You get the idea. But for us, today, we're zeroing in on that very first section, the one responsible for holding up and moving the head, the cervical region. In other words, the neck. Okay, so we've seen the whole column from a distance. Now let's zoom way in and look at just one single vertebra, one of those fundamental building blocks of this entire incredible structure. I want you to think of a typical vertebra as like a basic blueprint. It doesn't really matter where it is in the spine. It's almost always built from these 3 main parts: a body, an arch, and these various little projections that are called processes. So on the left, you've got our simple blueprint, right? Now look at the images on the right. This is the real deal. You can see how that basic plan gets tweaked and modified. See how the thoracic vertebra has those extra little facets where the ribs have to attach? Or how the lumbar vertebra is just so much bigger and beefier to carry more weight? It's the same basic plan, just adapted for totally different jobs. So what do these parts actually do? Well, the body is the main weight-bearing part. The arch creates that protective tunnel for the spinal cord. And the processes, both the spinous one that sticks out the back and the transverse ones on the sides, they act like anchor points for all the muscles and ligaments. They're what allow for both movement and stability. Now, while most of those vertebrae follow the typical blueprint, the neck has 2 unique superstars. These guys basically throw the rulebook out the window to give the head its incredible mobility. So let's meet the first 2 cervical vertebrae, C1 and C2. These 2 are considered atypical because they are so highly specialized. I mean, their unique shapes are entirely dedicated to giving the head its amazing range of motion. They absolutely work as a team, but they have very, very different jobs. First up is C1, the Atlas. And yep, it's named after the Greek Titan who held up the heavens because the Atlas literally holds up the skull. The joint it makes with the skull is what allows you to nod your head. It's the yes motion. Just look at how different the Atlas looks. As the source material points out, it's missing a true body, that big cylindrical part we saw in the blueprint. Instead, it's pretty much just a ring of bone with these large bony plates or wings on the side. The whole thing is perfectly designed to cradle the base of the skull. And its partner, the second superstar, is C2, the axis. So if the Atlas says yes, the axis is what lets you shake your head no. Its entire job is to provide a pivot point for the Atlas and the skull to rotate around. And the secret sauce to this whole movement is a totally unique feature called the dens. It's this peg-like bit of bone that sticks straight up from the body of the axis and fits perfectly inside the ring of the Atlas. It creates the perfect pivot. And that's it. This elegant little connection, the atlantoaxial joint, is a classic pivot joint. The ring of the Atlas just spins around the dens of the axis, and that's what gives your head all that freedom to turn from side to side. Pretty cool, huh? Okay, so now we've got the blueprint for a typical vertebra, and we've met its superstars, the Atlas and axis. Now let's see how evolution has played with this design across different animals to suit their needs. This right here is where we really see that idea of form following function come to life. So let's start with a little numbers game. Just look at this table. Cattle, horse, dog, humans. They all have 7 cervical vertebrae. Even a giraffe, with that crazy long neck, has only 7. But then look at poultry. A chicken has 14, double the number. And that's a huge part of what gives them that incredible flexibility. Let's start with the ox. Its atlas is, well, it's a trapezoid. You can just see how wide and robust this thing is with wings that slope outwards. This is a structure built for one thing, pure strength. It has to support a heavy head that's used for grazing and for defense.
Now, if you compare the ox to a horse, you start to see these subtle but really important differences. The dens on the ox's axis is wider, but check out the horse's axis. Its spinous process is absolutely massive. This creates a huge anchor point for something called the nuchal ligament, which is this thick band of tissue that acts like a natural support cable, helping hold up that long, heavy head without the horse needing constant muscle strain.
And now for the dog. Right away, you can see these bones are just built on a totally different scale. They aren't designed to support massive weight like an ox or a horse. They're built to allow for the quick, sharp, agile head movements of a predator. The dog's atlas has these wide, flat wings, and instead of a fully enclosed hole for nerves and blood vessels, it often has an open alar notch. You can think of it like a little shortcut for all those structures. Its axis is also pretty remarkable. It has this long, blade-like spinous process that actually extends forward over the top of the atlas. This gives the muscles extra leverage for that classic, curious head tilt. And finally, we have the fowl, which is just a completely different design philosophy. The atlas is just a simple, delicate little ring. Why? Because a bird's skull connects to its spine with only a single point of contact. One little bony knob called an occipital condyle, unlike the two that we see in mammals. So the single pivot point, combined with those 14 vertebrae, is what allows a bird to have that jaw-dropping range of motion. So we've seen everything from the powerful, sturdy neck of an ox to the hyper-flexible neck of a chicken. What's the big takeaway from all this? The big takeaway from this whole tour is that every single curve, every little projection, every hole in a bone, it's a clue. It tells a story about how that animal lives and moves. A grazer's neck is built for strength, a predator's is built for speed, a bird's is built for precision. And that, of course, leads to one final thought. What about our own 7 cervical vertebrae? What kind of story do they tell about us, about bipedalism and tool use, and our own unique evolution?